A combined inequality, which we also call a compound inequality, looks like this. It looks like a number n less than or equal to ax plus b less than or equal to m. It's just an example of a combined inequality where we have two inequality signs pointing in the less than direction, and we have the value containing x. Well, we'd like to eventually get it in the middle, of course, alone, but the expression with x is in the middle, and we have numbers on both ends. And of course, the smaller number will have to be on the left and the larger number on the right. Well, the thing I want to tell you here is that this expression may also be written as the intersection of two parts, and those parts are n less than or equal to ax plus b. And of course, you can look at the inequality and see that's true. N is less than or equal to ax plus b. But that would be intersected with the word and with the rest of it, which is the other side says ax plus b is less than or equal to m. So you see, we can split one of these combined inequalities into the intersection of two inequalities. Now, but what I want you to notice is that we have an and, the word intersection, combining these two parts together. And what you must remember is this only works, splitting up a compound or a combined inequality. You can only split them up with the and expression. It makes absolutely no sense to try to do this decomposition, splitting it up with the or the union expression. It does not work. So when you see one of these combined inequalities like we have on the top, those guys can be split up into the intersection, not the union, but the intersection of two smaller inequalities. Now that's going to become important in this next example. We have negative 3 less than or equal to x less than or equal to 0. Let's think about this simple example. If we graph this, we have our number line. We have negative 3 on the smaller side, 0 on the larger side, shade everything in between, put boxy brackets on both ends because both sides have equal portions. Okay, so the question is this the same as, I'm going to try to decompose it into two pieces like we did above. Negative 3 less than or equal to x. Well, that's certainly true. I can see that negative 3 is less than or equal to x in the original question. Intersected with x less than or equal to 0. Is it? Is it the same as the original question? Of course it is. Yes, it fits the example. Yes, that's true. And it's true because negative 3 less than or equal to x is the same as x greater than or equal to negative 3. Now, knowing this, now do we know this is true? Have you seen this before? If you turn the expression negative 3 less than or equal to x backwards, you have to be sure to flip the inequality sign with everything else. So yes, negative 3 less than or equal to x is the same as saying x is greater than or equal to negative 3. Okay, now, we know that the expression with the union, the intersection symbol, the upside down U, we know that's true. It's true because of what we said above. So we know that negative 3 less than or equal to x intersected with x less than or equal to 0. We know that's true. Okay, now we just rewrote the first portion of that where it says negative 3 is less than or equal to x. We rewrote that as x greater than or equal to negative 3. So now we can decompose this combined or compound inequality into 3 stacked number lines. The first expression, negative 3 less than or equal to x, we write as x greater than or equal to negative 3. And we draw a number line, and we put the intersection. We're going to intersect that with the second inequality, x is less than or equal to 0. And then the result will be the final picture. So for x greater than or equal to negative 3, well, let's stack up the negative 3's above each other, stack up the larger number 0. For the first one, we're going to shade everything that's greater than or equal to negative 3 with an arrow. For the second one, we're going to shade everything that's less than or equal to 0 with an arrow, and boxy brackets for both of these, by the way, because they have equal portions. And now we're going to take the intersection. So remember, you have to check each of the regions to the left of negative 3, in the middle between -3 and 0, and on the right side. When you do that, you're going to end up with shading only in the middle with boxy brackets on both sides. Now, the interesting thing in this example is that what we just wrote looks exactly like the original question. Look at it. So it was just a demonstration to you that you are allowed to take a combined or compound inequality. You could bust it up as an and statement. Or better yet, if you have an and statement and you stack those number lines like that, you'll end up with a compound inequality when it's this type of inequality. It was more of a demonstration than anything else.